I'm Eric Shea, I'm a data scientist and an ecologist.
I'm Paulo Arantes, I'm a data scientist and a business degree.
And I'm Jeremy Beal, and I'm a software engineer and a business degree.
So we picked the Caterpillar Challenge with driver data and events, so failure events. Well, we realized that we're not domain experts, and we wanted to simplify a very complex problem into a very simple solution. We're going to two parts. One is, how do we have these inexperienced or young drivers, and how do we make it real-life training for them? And how do we simplify that part of training? So one thing we don't want to do is give them all these unnecessary information when they're driving. So eventually what we built is a real-time feedback just using a machine learning algorithm, given all these sensors going with the machine, and simplify down to 5 seconds with one single probability.
My name is Abdul. I'm in my second year of my master's degree in electrical engineering.
My name is Rowan, I'm 22, and just like Abdul, I'm in the same cohort as him. I'm studying electrical engineering.
I'm Ashwin. I did the same bachelor as these guys in electrical engineering, not in master's at the moment, just working at UWA.
I'm Tom, I'm 21 too. I'm doing the Masters of Professional Engineering with these two guys.
We worked on the returns and rationalization problem, trying to reduce the amount of items that looks like was getting returned.
Hi. Last year we founded Petrodollar Science as the world's first data science company for the mining industry. And earlier this year we entered the Brisbane Unearthed hackathon because we thought Eucharist Pump Breakdown Challenge would be an excellent opportunity to showcase what data science can do for the mining industry.
Hi everyone, I'm Karina, part of Team DataCake, a group of talented data scientists and students passionate about helping companies to exploit the full potential of their data. We won Unearthed Sydney by solving the challenge to improve and predict the production of alumina for South 32. The production of alumina is based on a technology called Bayer process, and this process is monitored by more than 7,000 sensors, collecting data every 6 seconds.
Greetings from the Great White North. My name is Dr. Brian Lynch. I'm a postdoctoral fellow at Carleton University and also an adjunct professor at Queen's University. I have a background in aerospace engineering, and my research interests are in the field of planetary exploration and mining in space. Last year, I jumped at the opportunity to participate in the ORX competition held by Unearthed, and my solution was impressive enough to win first prize. The competition was brought to my attention by Professor Joshua Marshall at the Queen's University Mining Systems Laboratory, where I worked as a postdoc researching autonomy and robotics applications in mining.
Hi, I'm Quentin.
And I'm Lyndon.
And we're part of the team Conveyors of Wisdom. And we won Unearthed's Mind Hack event run for BHP Billiton earlier this year in Perth. Now, we took on the wear monitoring challenge. Now, conveyor belts, the wear is measured only every couple of months or so by hand at just one point along the belt and about 20 points or so across the belt. But we came up with a solution that measures the entire 3D belt surface in detail continuously using just a video camera and some clever algorithms.
I'm Tim.
I'm Jeremy.
I'm Will. And we are Team Unearthed. We are the inaugural winners of the Hunter Valley Hackathon held in August this year. We worked on the challenge by the Geological Survey group, which was automating image analysis for drill core samples. The challenge involved using RGB data and cross-referencing with line scan data to produce some mineral maps of the drill core samples.
I think, yeah, as a team of individuals, we were quite interested in coming together and trying to create something marketable and potentially take this a lot further. And not just this particular example, but a lot of data science things in particular. But I don't think we'd ever consider it as being a university project. This was a project for us.
So the mining industry has so much data. This is probably just the beginning of how data scientists can influence that industry to shape it from forwards going with technology. And just to be completely clear, like, it's not that data science is going to replace people with those super smart machine learning algorithms, but we think that if we would keep developing these algorithms, we would include the human in the loop. The machines makes your job as a human, as an operator, easier, but it's also just the beginning. Your input based on what the machine suggested, it's gonna retrain the model in real time to become smarter and make better suggestions so you can have a better performance.
and this generated more than 177 million rows of data every year. Using traditional techniques, it was almost impossible for South32 to be able to use these huge data sets to optimize the process. Our team has used different techniques, such as big data and machine learning techniques, to be able to design an accurate predictive model of the production yield. We also worked closely with South32 all along on this project to confirm our hypothesis and make sure we were always in line with the business requirements. This project has really helped South32 to get an understanding of the potential of advanced analytics and how it can really bring value back to their business. And they are now exploring new ways to leverage from their own data and transform it into a real asset.
Following the Unearthed Brisbane, we kept in touch with Newcrest, and not long afterwards they scheduled a meeting on site to investigate the potential application of our algorithms, which we've trademarked as Forestall. This on-site meeting led Newcrest to engaging us to solve a similar challenge with a different pump, and has led to a series of ongoing Forestall engagements with Newcrest. Since the hackathon, we've seen a big increase in our machine learning prediction revenue growth, and that probably wouldn't have happened without the Unearthed event. So thank you very much to those, the Unearthed organisers. I think it was a really good initiative and has allowed direct contact between the problem solvers and those companies with the significant challenges.
Since the MindHack event, we formed a company called Warehawk. We've submitted a provisional patent, and just recently we visited a mine site to scout out conveyor belts that would be suitable for conducting our first field trials. We're continuing development towards a commercial product. It was great to work on real-world problems, so thanks very much to BHP Billiton and to Unearthed for giving us this opportunity.
Yeah, so keep an eye out for Warehawk technologies on a mine site near you.
Although my background is in aerospace, I have experience working with computer vision and machine learning and was able to apply that knowledge for the ORX competition. Since then, Goldfields has successfully deployed my algorithm in their operations, and I've been working with GlassTerra to commercialize the system for future applications. The competition was structured in a way that made it very easy to work with the data and interact with both Unearthed and GlassTerra through their Q&A forum. These types of competitions can be a real asset to private industry, since there are many fresh young minds like myself who are eager to apply their skills for solving real-world problems in a competitive format. And frankly, the value of the solution far outweighs any investment in terms of prize money. I hope to participate in many more Unearthed endeavors, and I fully encourage other researchers and industry members to get involved in the future. Bye for now.